So at this point, you should already know how to find maximum and minimum points on a function just by taking the derivative and setting it equal to 0 to find a horizontal tangent line, and by testing out the endpoints of your domain. And that's the strategy we're going to be using to solve these optimization problems. And for example, let's say we have this function x squared plus 4x plus 5. Let's say this is f of x. And we want to find a value x such that the output is like the smallest possible. So we're optimizing it by making the output a minimum. And to do that, you already know that we should take f prime of x, and we get 2x plus 4. We set it equal to 0, and we get x is equal to -2. And to prove that this is a minimum or a maximum, we take the second derivative, f double prime of x, we get is equal to 2. And when the second derivative is positive, that means you have a minimum. So yes, at x equals -2, this function will output a minimum value. So let's do an example of a real optimization problem that you might have to do. Let's say we have two numbers, and the sum of the first number and twice the second is 64, and the product of the two numbers is a maximum, or is as big as possible. At first, let's declare a variable. So the first number, we can set it equal to x, and the second number, set it equal to y. And because we can already write one equation from this information, that the sum of the first number plus twice the second is equal to 64. But this isn't enough to find out the values of both x and y. But we're given that the product is a maximum, and the product is just x times y, and this is going to be our function. So we can write f of x is equal to x times y, and what we would want to do is find f prime of x and set it equal to 0, but since we have y, there's two variables, it's kind of hard. So because this is f of x, let's try to find y in terms of x and then substitute it into here. So 2y is equal to 64 minus x. Y equals 32 minus x over 2. And then we can plug that into here. So f of x is equal to x times 32 minus x over 2, or 32x minus x squared over 2. So what we can do here is find f prime of x now pretty easily. It's just 32 minus 1/2 times 2x, and this is going to just be 32 minus x. And now we set it equal to 0, and we get x is equal to 32, and y is equal to 32 minus 32 over 2 using this equation, and we get y is equal to 16. And this is our answer. X equals 32 and y equals 16. So one of the numbers, or the first number, is 32, and the second number is 16. Now let's get into some practice problems. If you think you know how to do this one, pause the video and try it. This one says a rectangle is inscribed in a semicircle with radius 16 centimeters. What is the largest possible area of the rectangle? So first, let's draw a picture to help us understand it better. Say this is our semicircle, and we have this rectangle inscribed in it. First, let's draw an equation for our semicircle, and the equation for a circle is going to be x squared plus y squared is equal to 16 squared, or 256, because the radius is 16, and y is going to be equal to square root of 256 minus x squared. And it's not going to be positive or negative because since this is a semicircle, all the values of y are going to be positive. So just this. And now let's write an equation for our rectangle. Our area is equal to the length times width. But you can tell our variables aren't going to be consistent. So let's set this, let's say this is the width, set this equal to in terms of x. And let's look at our equation for the circle. Y equals whatever this is. And if we have a point on our circle, y is going to be how far it is up from the x-axis, or the height of the point. And we can use the same for a rectangle, so we can set the height of a rectangle equal to y. And the x is going to be how far it is to the right of the y-axis, which means that our x is not just going to be the whole thing, but the right half of it. So let's say we can set the right half equal to x, and because the rectangle is going to be symmetrical over the y-axis, we have two x's. So our area is going to be 2x times y. And we already have y in terms of x, so we can rewrite our area equation just replacing that. So let's write it as an actual function. A of x is equal to 2x times square root of 256 minus x squared. And that's going to be this function that we're going to try to derive, because we're trying to find the largest possible area of the rectangle. Now we have our area in terms of one variable, and we can find a prime of x. And using the product rule, we can figure it out. 2x times 1/2 times 256 minus x squared to the power of negative 1/2 times negative 2x plus 2 times the square root of 256 minus x squared. And now let's try to simplify this. We're going to get equal to x times 1 over the square root of 256 minus x squared times negative 2x plus 2 times square root of 256 minus x squared. And further simplify this, we get negative 2x squared over the square root of 256 minus x squared plus 2 times square root of 256 minus x squared. And now, again, to find the maximum, we would set it equal to 0, because this is the derivative. And then we can factor out a 2, or let's factor out a negative 2 from this and divide both sides by it. So this is going to be turned into minus this. And let's try to get rid of this fraction by multiplying both sides by square root of 256 minus x squared. And that will not change the left side, because it's just 0, and anything times 0 is just 0. So now this is our equation. X squared minus 256 minus x squared is going to be 0 equals 2x squared minus 256, and 256 is equal to 2x squared, or 128 is equal to x squared, or x is equal to square root of 128. And we can simplify this further. The square root of 128 is going to be 2 times the square root of 32, or 4 times the square root of 8, or 8 times square root of 2. So x is equal to 8 times the square root of 2. And we have, this is just one of our sides. It's not one of our sides, it's actually half of a side, because again, this part of the rectangle is 2x. So this part is going to be 16 times square root of 2. Now let's try to find the height. And we already had y, but we kind of lost it, so let's try to rewrite everything again. So again, x is equal to 8 square root of 2. And now let's try to find y. Let's rewrite our circle formula. X squared plus y squared is equal to 256, or y squared is equal to 256 minus x squared, y equal to square root of 256 minus x squared without positive or negative because it's a semicircle. And let's plug in that for x. Y is equal to the square root of 256 minus 8 square root of 2 squared, which is equal to square root of 256 minus 64 times 2, which is equal to the square root of 256 minus 128, or square root of 256, square root of 128. And this is going to be, we already simplified this earlier, it's just y is also going to be 8 times square root of 2. So now we have both of our dimensions. The width is 16 times the square root of 2, and the length is 8 times the square root of 2, or vice versa, whatever you want to call the length and width. So now to find the largest possible area, all we have to do is multiply these two together. So 8 square root of 2 times 16 square root of 2. This is going to be 16 times 8, which is 128 times 2, which is 256 centimeters squared. And that's our final answer. Now, let's do another practice problem. If you think you know how to do this one, then pause the video and try it. This one says, you have 20 meters of fencing to build a pen against a barn, and we're assuming the barn already exists. Find the maximum area of the pen. So let's draw our barn, and let's draw our pen, and we're going to find the maximum area of this pen. And let's write an equation for our perimeter. So 20 is equal to 2x plus y if we label this side as x, and y. And it's not 2y because one of the sides is already covered by the barn. So we only need 2x and 1y. And our area equation is going to be x times y, as always. But let's try to get this in terms of one variable. And we can do that by isolating y in this equation. Y is equal to 20 minus 2x. It's pretty simple. And then now we have our area is equal to x times 20 minus 2x, just by replacing the y. Or our area is equal to 20x minus 2x squared. And let's say this is our function, a of x. And now we need to find a prime of x and set it equal to 0 to find the maximum. So a prime of x is equal to 20 minus 4x, and set it equal to 0. We get negative 4x is equal to negative 20, or x is equal to 5. So now we have one of our sides, x is equal to 5, and find y, we can plug it into here. Y equals 20 minus 2 times 5, or y equals 10. Now we have our two sides, and to find the maximum area, we just multiply them together. Pretty easy. 5 times 10 is equal to 50, or 50 meters squared. And that's our final answer. So everything that I explained and all the problems that I went through should give you enough knowledge to solve basic problems about optimization. And remember, this concept isn't really anything new. It's just applying what you already know about derivatives into real-world situations, or like word problems. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.